Oh, look at the pretty leaves. Ladies and gentlemen, Section 7, Chapter 3, last section of this, I guess we'll call unit of CPC, and beyond. We're going to learn two theorems in this short little video, and it's going to be answering the question of how do you use the angle side theorems in geometry. So let's go. I'm going to do this actually through a proof. I'm going to do a proof with you. You need to copy down the proof. We'll go through all the steps together, and then I'm going to show you how you can use these angle side theorems to make the proof do the proof a different way. Let's do it. Alright, here we go. So here's your proof. You probably have to pause the video and copy all this down, but I'm going to keep rolling. So here's the given. You got MA over here, that is, and MH are the legs of isosceles triangle. So we got triangle HAM is isosceles, and these are the legs, so MH and MA. And we have S is the midpoint down here of segment HA. And what we're proving is angle A and angle H are congruent. So essentially what we're proving is the base angles, you can see that in the picture, the base angles of the isosceles triangle are congruent. That's the deal. So we're given an isosceles triangle and we're proving that these base angles are congruent. So let's do it. Well, here's the first thing. How can we do this? Let's get a couple things that we actually know. Well, I know legs of isosceles triangle are congruent, so let's do that in step number 2. Let's put step number 2, we'll put MA is congruent to MH. MA is congruent to MH. That is a statement that is true. Here would be my reason. Legs of an isosceles triangle are congruent. There you go. And if you want to write it in conditional statement form, you can. If a triangle is isosceles, then the legs are congruent. That's great. But this is fine, just a straight up statement. Legs of an isosceles triangle are congruent. So we have that. Now let's change colors. Let's use this information right here. S is the midpoint. If S is the midpoint, that means AS and HS are congruent. So let's write that as a step. So AS is congruent to HS. Our reason is if a point is the midpoint of a segment, then it divides the seg into two congruent segments. Straight up definition of midpoint. Beautiful. So here's where we get stuck though, because again we're trying to show, the goal is showing angle A congruent to angle H. Well, let's do this. What if we created two triangles by drawing this segment, or this segment straight down here like that? So if I drew that segment straight down there, straight as I could draw it on this thing, that's a little better. There we go. Now what I'm doing is I've drawn this auxiliary line to create two particular triangles that contain this angle A and angle H that I'm trying to prove congruent. That's beautiful. We just have to remember to take care of that properly in a proof. How would we put it? We would just put draw MS, and remember our reason is 2 points determine a seg. Beautiful. So once we get those 2 points on there, or the actual segment, the auxiliary line drawn, now let's finish this bad boy. So we can say MS is going to MS, step number 5. And the reason is reflexor property. Cool? And I know you could have actually maybe paused this and done this yourself just to see if you could do it. Wouldn't be a bad idea. But anyways, here we go. So MS is going to MS. Now we got everything that we need. So let's prove the triangle is congruent. So step number 6. Boy, I'm getting all kind of colorful here. So we'll go triangle SAM is congruent to triangle, what would it be? So if I went from S over to A up to M, that means I got to start with S, go over to H, and then go back up to M. So there we go. Our reason is side, 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 and we got some numbers. We got here in step 2, we got a side, or sorry, yeah, step 2, Mater, come on. Step 3, we got another side, and step 5, we got our third side. So there we go. So we got those two triangles congruent, and that's awesome because they contain, hello, the two things that we actually need. So step number, finally, 7, woo, we got there. Angle A is congruent to angle H. That's this angle right there, and that angle right there. And we can say that they are congruent because of CPCTC. Yay! Great rejoicing. So good job. So there you go. It's 7 steps. You can easily do it from everything that you know at this point, guys, right there. We just used legs of an isosceles triangle, midpoint, we drew a line, reflexive property, got the triangles from going through side, 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 and then we use CPCTC. However, wouldn't it be nice, here we go, wouldn't it be nice if we could do this proof in a lot less steps? And I'm going to propose to you this. Let me actually get my eraser out here. You ready? I'm going to propose to you that we can do this in not only 7 steps, we can actually get rid of this. We can get rid of this step. We can get rid of this step. We can get rid of this step. Oh yeah, keep going, Mater, keep going, Mater, keep going, Mater. We can get rid of all this stuff. In fact, we can get rid of step number 2, kind of. And if I could erase all this, which would be great. You know what, I'm going to stop talking and speed all this up. Okay, so beautiful. So I've erased everything that we had right there. Here's the deal. I'm going to be able to show you how to do this proof in not 7 steps, not 6, not 5, not 4, not 3. I'm going to be able to show you how to do this in only 2 steps. That is correct. Now, if you're not sitting there rejoicing, doing cartwheels around your room, I don't even know, singing like, yeah, you should be, because I'm showing you how to do this in 2 steps. And the only way that we can do it is by using the theorem that is in this section. Let me present to you the theorem first, and then I'll come back and show you how it fits in this particular proof. So here it is, Theorem 20. It says, if 2 sides of a triangle are congruent, so that means this, and you should write this in your notes. If I have a triangle like this, or I have 2 sides of them congruent, like this side and that side. This particular theorem says if those 2 sides are congruent, or if I have another triangle, we'll just label it like this, whatever. Let me do it this way. Like that. So if we have, back that up. There we go. So a triangle that has 2 sides congruent. It says then the angles opposite those sides are congruent as well. What does that mean? It means this. This is the side that's congruent, so the angle over here that's opposite it, and the angle over here that's opposite it will be congruent. Likewise, if this side's congruent on that side, the angle over here, the whole way across the triangle, and the angle over here will be congruent. That is a shortcut for this particular theorem. And by the way, or that's a shortcut for the question we just did. But by the way, here's how you're going to write it in your proof. You can write all this out. You'll look in the sample problems in your book. It's written this way. It'll say this right here, sides imply angles. And you are more than welcome to. You're going to see me write it exactly like this in every 2-column proof that I do. So that is your reason why we can go from sides to angles. So basically it's the legs of an isosceles triangle mean the base angles are congruent. That's exactly what it means. So back to this. Here we go. So what I have in front of you is, again, back to this, where we were given, if I could erase all this. Actually, let me see if I can. How can I do this? I'm going to do it right now. Nope, that didn't work. Time out. I got it. There we go. So if I can erase all of this stuff right here, remember what was given to me. What was given to me is this. I had originally that legs were congruent. And remember, through 7 steps, we eventually got this angle congruent to that angle. So if you had to prove this one, here's what you would do. Step 1, you're given all this. It's great. This actually means nothing at all. You don't even need this. So as soon as you know 2 sides of a triangle are congruent, you could have done this in step number 2 by saying angle A is congruent to angle H. Why? Because if I have sides of a triangle that are congruent, check, check, that implies the angles opposite those guys are congruent. That could have been done right there in 2 steps. Now, go back and look at the one we did in class, number 12, that we did in class today, or whatever day it was. I don't even know what page it was. Number 12. I should know the page, but I don't. Actually, it's page 141. There you go. Page 141, number 12. If you look at that one, you'll see from the given information, we could have gone right to the actual conclusion by using this right here, this reason. And yes, it does go backwards. So if maybe, for example, you know that this triangle right here has these angles congruent somehow, so the given's different, then that would imply to you that you could conclude right away that these sides are congruent. So that particular theorem goes hand in. By the way, here's why. Because Theorem 21, says if I have two angles of a triangle congruent, so that's this one. If I have two angles of a triangle congruent, that would imply to me that I have the sides of the triangles congruent as well. So it's just the converse of this theorem that's right up here, theorem 20. So this is theorem 20, where I go from sides to angles, and theorem 21 says I go from angles to sides. So they go hand in hand, back and forth. And this right here is your reason in a two-column proof if you're given angles and you want to go to sides. Look at your sample problems and rock and roll. We'll see you guys in class, and that's it. Later.